Good morning, students. In previous lecture, we discussed about different properties of DTFS, discrete time Fourier transform, DTFT. Now we will discuss some more property of DTFT and then solve the problem on DTFT.
Hello, ma'am.
Hello, 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 आरू
यस मैम।
आवाज अभी नहीं क्लियर थी क्या?
मैम अभी तो आवाज ही नहीं आ रही थी, अब आई है।
ओके, चलो ठीक है। ओके, कन्वोल्यूशन। हाँ, हेलो, आप क्लियर है? अनुजा, आरू,
क्लियर है।
ओके। Multiplication. Next property is multiplication. If Fourier transform of x of n is x of exponential j omega and Fourier transform of y of n is y exponential j omega, and if we multiply x of n and y of n and take the Fourier transform of this multiplication, then by definition of Fourier transform, we get this expression summation y of n x of n exponential minus j omega. And if in this expression we put the IDFT of x of n, IDFT of x of n, then we get this 1 by 2 pi integration x of j omega j theta multiplied by this d theta. And if we take 1 by 2 pi integration x of exponential j omega j theta, out of this summation sign we get this expression, and this is the this is y of n multiplied by exponential minus j omega theta minus n is simply y of exponential minus j omega theta. So if we multiply this x of j omega theta multiplied by y of j omega theta omega minus theta d theta, and it is multiplied by 2, it means that this is the convolution of x of e j omega and y of e j omega. It means that if two signals are multiplied in time domain, then their Fourier coefficients are convoluted in frequency domain. Then next is Parseval's relation. If Fourier transform of x of n is given by x of exponential j omega, then this is the energy of x of n. So energy of signal is given by this formula. How can we calculate the energy of signal? Summation n is equal to minus infinity to plus infinity. The square of mod of x of n is also written as summation from minus infinity to plus infinity conjugate of x of n multiplied by x of n. Then we substitute the value of x of n by IDFT. when we substitute the value of x of n in this formula, and if we take 1 by 2 integration x of exponential j omega out of this summation sign, we get this expression. Then conjugate of x of n can be written as summation x of n exponential minus j omega. This plus is converted into minus, and then here we put the conjugation sign multiplied by d omega. And this is the Fourier transform of conjugate of x of exponential j omega, and we can write this like this. And partial theorem is used when it is difficult to calculate energy or power of signal in time domain. We can simply calculate the Fourier transform of discrete time signal, and then this is the area of square of x of exponential j omega theta. And first we calculate the Fourier transform of x of n, then we square that term, and then we calculate the area of that signal in frequency domain, and if we multiply 1 by 2 pi, then we get the energy of discrete time signal by using Parseval's theorem. Here we solve some, here we determine DTFT of some standard signal. Determine the DTFT of unit impulse delta of n. If x of n is delta of n, then according to the definition of DTFT, x of omega is given by summation n is from infinity to minus infinity to plus infinity x of n exponential minus j omega. Then substitute the value of x of n, which is in this case del of n or delta of n. So delta of n is this, and we know that delta of n exists only at n is equal to 0. Del of n is 1 for n is equal to 0, and it is 0 elsewhere or otherwise. So we can say that x of omega summation at n is equal to 0, because this delta function exists only n is equal to 0, and 1 is multiplied by j exponential minus j omega n, which is equal to 1 plus exponential 0, and value of exponential 0 is 1. So we get the value of Fourier transform of delta n is 1. Next, calculate the DTFT of unit step u of n. X of omega is given by summation x of n exponential minus j omega. Substitute the value of x of n, which is unit step u of n. So this unit step exists only for positive value of n. So this limit changes from minus infinity to 0. X of omega is given by summation n is from 0 to infinity, and value of un is 1. 1 is multiplied by x of minus j exponential minus j omega n. Then x of omega is equal to summation n is equal to 0 infinite, and we can write this expression like this, and this is an arithmetical series, and sum of arithmetical series is given by, if n is equal to 0, from n is equal to 0 to infinity, a raised to power n is given by 1 by 1 minus a. If value of or magnitude of A is less than 1. Here we suppose that A is equal to exponential minus j omega. So we get the value of Fourier transform x of omega is equal to 1 by 1 minus exponential j omega. Now if we put omega is equal to 0, if here we put omega is equal to 0, then we get 1 minus 1 is 0 and we get x of omega is infinite, which is not desired. So we here exponential 0 is 1 and this one can be written as exponential minus j omega by 2 exponential plus j omega by 2. So we write this one is replaced by exponential minus j omega by 2 multiplied by exponential j omega by 2, and this exponential minus j omega is simply written as exponential minus j omega by 2 multiplied by exponential minus j omega by 2. Here then we take x of then we take exponential minus j omega by 2 common from this equation and we get exponential j omega by 2 minus exponential j omega by 2 divided by 2 is j sine omega by 2, and so x of omega is written as 1 by exponential minus j omega by 2 multiplied by 2j sine omega by 2. So this is the formula for Fourier coefficient of unit step function. Next, obtain Fourier transform of single-sided exponential pulse. X of n is equal to a raised to the power n multiplied by un. Here a is some constant and un is unit step function. Then according to the definition of DTFT, x of omega is given by sine n is from minus infinity to plus infinity x of n x multiplied by exponential minus j omega n. And if we substitute x of n is equal to a raised to the power n un, due to presence of this un, this limit changes from minus infinity to 0, and so we get x of omega is summation n is from 0 to infinity a of n, a raised to the power n exponential minus j omega n. And this expression can be written like this, and this is geometrical series, so we can calculate the sum of the sum of this geometrical series is given by 1 by 1 minus a exponential minus j omega. Similarly, obtain the DTFT of left-handed exponential signal x of n a raised to the power minus n u minus n minus 1. Here it is a raised to the power minus n. Then we substitute the value of x of n into this equation here, and a is from minus n and exponential, this is exponential minus j omega n. If we substitute in this equation, if we substitute n is equal to minus n, expression x of omega is equal to summation L is equal to 1 infinity a raised to power L exponential plus j omega L. And this expression can be written like this, which is in geometrical series. This, and we can find the value of x of omega is equal to a exponential j omega divided by 1 minus a exponential j omega. Then find the DTFT of double-sided exponential. Simply substitute the value of a raised to power n u n, which we have calculated 1 by 1 by 1 minus a exponential j omega, and put the value of this, and you get the Fourier series of this expression. Fourier transform. Then obtain DTFT, discrete time Fourier transform of a rectangular curve. X of n is a when n is equal to or less than L minus 1. L is the length of rectangle, or length or duration of rectangular curve. So x of n is equal to a when when n is less than or equal to L minus 1 and greater or equal to 0, and x of n is 0 otherwise. X of omega is given by summation x of n exponential minus j omega n, and but x of n is present only in the range from n is equal to 0 to n is equal to L minus 1. Otherwise, it is 0. So, x of omega, this limit is changed to with n is equal to 0 and L minus 1. So, x of omega is given by summation a exponential minus j omega n. A is constant, so we take this term out of the summation sign, and this is, we can use the standard summation formula. Summation a raised to power k is given by, if we take a is equal to exponential minus j and n1 in this case is 0 and n2 is L minus 1. N2 is L minus 1, n1 is 0, and a is exponential minus j omega. So x of omega can be calculated by putting the value of this on this a value of a, n1 and n2 in this formula. We get x of omega is equal to a 1 minus exponential minus j omega n divided by 1 minus exponential j omega. As in previous question, we also arrange this equation. One is replaced by exponential j omega by 2 multiplied by exponential minus j omega by 2. Similarly, exponential minus j omega is replaced by exponential j omega by 2 multiplied by exponential j omega by 2. One is replaced by exponential j omega L by 2 multiplied by exponential minus j omega L by 2, because in this case, in the numerator, here exponential minus j omega L, this term is present. So here we take capital L. We are also include this capital, and exponential minus j omega l is written as exponential minus j omega l divided by 2 multiplied by j minus j omega l by, and j exponential minus j omega l by 2 common from numerator, and exponential minus j omega by 2 common from denominator, and we get this x of omega is equal to a exponential minus j omega multiplied by l minus 1 divided by 2 sin omega l by 2 divided by sin omega. Next question is obtain DTFT of a signal x of n is equal to r raised to the power n cos omega naught n u n when r is less than 1. According to the definition of DTFT, x of omega is written by this formula, and if we substitute value of x of n in x of n, since un is present, so limit is changed, from n is minus infinity to n is equal to 0, and x of omega is summation r raised to power n of omega naught n exponential minus j omega n. Cos omega naught n can be written by this minus identity, so we replace cos omega naught n by this expression, and if we solve this expression, we get this summation n from 0 to infinity r raised to power n exponential omega naught n multiplied by exponential minus j omega n plus summation r raised to power n exponential minus j omega naught n multiplied by exponential j omega n. And this equation can be written in this form. This equation is written in this form, and it is a geometrical series, so we use this geometrical series formula. This can be written in this, and this is written in this form. And if we simplify expression, then we get x of omega is like this. Numerator can be written as this, and it is in simplified form. Numerator is in simplified form like this, and exponential minus j omega naught plus exponential plus j omega naught is replaced by 2 cos omega naught. So numerator is simplified in this form. Similarly, denominator is simplified these steps in these steps, and denominator is simplified by this. If we substitute the simplified form of numerator and denominator, we get the value of x of omega. X of omega is 1 by 2 multiplied by this. obtain the DTFT and state the magnitude spectrum of x of n, and x of n is given by u of n minus u of n minus 1, n minus 4. x of n is given by u
मैम
of
आपकी आवाज नहीं आ रही है।
सबसे नहीं आई। हेलो हेलो आरू, अब आवाज क्लियर है? गौरव,
मैम क्लियर है।
फैन की वजह से जो है थोड़ा डिस्टर्बेंस।
यस मैम।
ठीक है। Obtain DTFT and scale the magnitude spectrum of x of n. And x of n is given by u of n minus u of n minus 4. So x of n is given by here. This is u of n. U of n is given by this, and u n minus 4 is given by this. If we subtract u of n minus 4 from u of n, then we get u of n minus u of n minus 4 is simply 1, 1, 1 and 1. It means that x of n is written as 1 when n is 0, 1 when n is 1, when 1 when n is 2, and magnitude of n x of n is 1 when n is 3. So substitute the value of x of n in x of omega, we get this 1, and n is from 0 to 3, we get the value of x of omega exponential 0 exponential minus j omega plus exponential minus j 2 omega plus exponential j 3 omega. So we get x of omega. Value of x of omega is given by this 1 plus exponential minus j omega plus exponential minus j 2 omega plus exponential minus j 3 omega. And magnitude of x of omega is given by simply if we take square of real part of x omega and square of imaginary part of x of omega, then we get this x of magnitude of this is 1, magnitude of exponential minus j 2 omega is 1. Similarly, magnitude of exponential minus minus j 3 omega is also 1, and this is a magnitude of 1 plus 1 plus 1 plus 4, and magnitude of x of omega is 4 for all values of frequency or omega. Clear? Now class is over. Thank you.
रितेश एक सेकंड होल्ड कर, एक सेकंड हैंग हो तो आपका हो गया ना, मीटिंग खत्म हो गया ना, तो क्यों टेंशन ले रहे हो? और बटन प्रेस कर दिया, उसको एंड करो और वापस क्रॉस
अलग अलग की प्रॉब्लम अलग अलग नहीं हो रही, मीटिंग एंड नहीं हो रही। मैंने स्टॉप शेयरिंग कर दिया, मेरे को ये